Hello, and welcome to another short tutorial video. In this video, we are going to basically talk about what a rate is, what a proportion is, and how to determine if something's proportional and how to find equivalent rates and ratios. So to get started, if you've ever heard the saying, that's like comparing apples and oranges. That saying means that there's two things and they're different, so you can't compare them. Well, a ratio is a mathematical answer to yes, we can, and we're going to. So lemons and limes, right? Lemons and limes. You're mixing a fruit punch. You have a ratio of lemon to limes is 1 lemon for every 3 limes. That doesn't mean you're only going to use 1 lemon or you're only going to use 3 limes. This is a relationship. So for every 1 lemon, you're going to have 3 limes. So a ratio is just a relationship between two things. If you have a young person they're looking at college, and it says that the ratio of teachers to students is 15 to 1. Well, no, that would be students to teachers is 15 to 1. That means for every 15 students, there should be 1 teacher. Okay, that's the relationship. So there's 3 ways to write a ratio. So the first way is to simply write it out. 1 lemon to every 3 limes. That's a ratio. You could also write 1 lemon, and you could use a colon. Instead of to every, you just put your colon there and then write 3 limes. So that's another way that you can write a ratio. The last way would be to write the 1 lemon and use it like a fraction. Put a fraction bar over 3 lines. A lot of times this is the way we're going to do it because this makes it easy to set up to another ratio with different numbers, but the same relationship. Okay, so that's how you can write a ratio. The next thing to understand is most of the problems you're going to do with ratios are going to require you to find a missing piece. So in order to do that, you have to have what's called equivalent ratios or a proportion. So two ratios that are equal is called a proportion. So I have some questions here, and the question is, are these 2 ratios proportional? Meaning, do they have the same relationship? So we're going to look at this first one. If you could drive 50 miles in 1 hour, okay, so there's my ratio, 50 miles compared to 1 hour. Or you could drive 200 miles in 4 hours. Is this the same rate? Is it the same ratio even though the numbers are different? And the way to check this, there's a couple ways, but probably the easiest way is called cross multiplication. Take the denominator of one times the numerator of the other one, and you just multiply. So we're going to multiply up that way, and then we're going to multiply over this way. If you get the same number for both of these, then they're the same thing. The ratios are the same. So 4 times 50 is 200. 1 times 200 is 200. And that means that, yes, these are equal to each other. It's the same ratio. So let's check another one. Say you have a classroom that has 4 girls compared to 5 boys, and another classroom that has 9 girls compared to 18 boys. Is it proportional? Is the equal sign here true? Well, 18 times 4. That might be hard to do in your head, but 18 times 2 is 36. 18 times 4 is 72. 5 times 9 is 45. So do these have the same ratio? No, not even really close. So you could slash that out. They are not equal. That does not make a proportion. Okay, so the idea of a proportion is 2 ratios that are equal. So the last thing that we're going to do with this is we're just going to try a couple problems from our, why are we here? I don't know. We're going to try a few problems from the textbook. So in Kaplan on page 261, right, this is the Kaplan book that you should have if you're working on your GED. from the IU 13. So we're going to take, we're going to look at number 7. A basketball player attempted 32 free throws. So 32 free throws is what the player attempted. All right, so he shot 32 free throws and made 20. All right, that's actually pretty good. I don't know. That's better than I would do. Made 20 shots. What's the ratios of free throws made? So here's what they want. They want made to free throws missed. Okay, now you might have been thinking, geez, Mike, this looks really easy. Like, why would they put this on the GED? It's too easy. Well, here's how they make it a little bit more complicated. They give you the total number of free throws and how many they made, but then they ask you for something that is not what they give you. So they give you free throws made and free throws attempted. They want a ratio of made to missed. So you know that the player made 20 shots. How many did they miss? Well, it didn't tell us, but we can figure it out. If you shot 32 and made 20, you could just subtract that. 32, if they made 20, that means they missed 12 of them. So if they made 20 and missed 12, is that your final answer? Well, if you look up in the starting directions on page 261, it says, write each ratio as a fraction in lowest terms. That means you have to reduce this. So you're not going to see this as your answer. It is correct, but it needs to be reduced. So you're looking at a 20 and a 12. You have to divide by something that they both have in common. Well, they're both even numbers, so I know I can cut them both in half and do 10 over 6. But now they're still both even, so I can cut them in half again and do 5 over 3. That can't reduce anymore. So your correct answer was B, they made 5 for every 3 that they missed. And that is your final ratio, okay? So that's your ratio, 5 made for every 3 that they missed. That's not bad. It's not bad. It's pretty good. Better than some of the MBA people, actually. All right, we're going to try one more off of this page, and then that's going to be it for ratio. Take a look at number 14. So number 14 has multiple choice. So a team played 77 games. So they played 77 games and won 56 of them. So they won 56 games. Watch out for your labels. What is the ratio of wins? So here's what they want, to losses. Again, a little bit tricky, The wins is easy. That's 56 games. They gave us that. But losses, they did not give us. But if they won 56, assuming that there's no ties, then they lost the rest of their games. So 77 minus 56, it looks like they had 21 losses. So this is where you've got to be able to do a little bit of reading. So they lost 21 games, they won 56. Can we reduce this? Well, it's a little tricky, but yes, we actually can. Now remember, on your calculator, if you don't know how to type this in and get it to reduce, make sure you ask me before you take the test, or Ann, or whoever, Jenna, ask somebody before you take the test. But you would type this in as a number and just hit enter and it'll reduce it for you. But the number that divides into both of these is 7. 7 times 8 is 56. So 56 divided by 7 is 8. 21 divided by 7 is 3. So you're looking for a win to loss ratio of 8 to 3. 8 to 3 is letter D. Okay. Good luck with ratios. Remember, they're a lot like proportions, so it's kind of a similar skill set. Good luck. I'll see you at the next lesson.